Hello, my dear students. I am Prashant here from Pragati School, Kadagudi. This is the online classes for students, especially for CBSE 10th students. This is chapter 1 of chemistry, which is chemical reactions and equations. We'll learn about chemical reactions. What do you mean by chemical reactions? The name says chemicals. That means chemicals are involved in what? In some reactions. Okay, we will see the definition of it. Chemical reactions are the processes in which new substances with new properties are formed. In simple line, chemical reactions are the processes in which new substances are formed. The new substance will have the new properties. For example, if you're seeing this picture, what do you understand? There is some left hand side, there are some balls here. Right hand side, there are some balls here with different colors. And in between, there is a arrow which is pointing towards right hand side only. What does you mean by? We will understand that better in the below definition. During a chemical reaction, atoms of one element do not change into those of another element. Only a rearrangement of atoms takes place in a chemical reaction. What is the exact meaning of it? I'll explain to you. So we'll come back to this picture. 1 minute. I'll come here. You are able to see this? Now it is better. If you come back here, you can see here there are three types of balls. Which types of balls? Three types of balls. Which are those? Blue color, red color, and white color. You can see here blue color ball. How many are there? Left hand side, it's one. Right hand side, how many are there? One. That means left hand side is equal to right hand side. Then white balls, one, two, three, four. On the left hand side, right hand side, one, two, three, four. Good. LHS is equal to RHS. Then red ball, how many are there? Left hand side, one, two, three, four. Right hand side, one, two, three, four. That means all the elements on left hand side is equal to all the elements in the right hand side. That means the elements do not change. What is changing here? See, blue color, one, two, three, four balls of white color are attached to blue color. But here, blue color is attached by two colors of blue balls here. That means that structure is changed. Elements remain same. Okay, elements remain same on the right hand side as in the left hand side, but what is changing? The structure is changing. See here, two red balls are here, so one red ball is here and it is attached with two white balls. One more red ball is here attached with two white balls, but arrangement is different. See the arrangement is totally different compared to the left hand side. That means, what do we say? That means once the chemical reaction occurs, when the chemical reactions occurs, the total structure, new substance is formed with new structure and new property. But the thing to remember is the elements on the left hand side remain same in the right hand side. Two things you should remember carefully. We'll see this also. See, one black ball is here, here one black ball, one, two, three, four white balls are here, here one, two, three, four white balls are there, and here one, two, three, four red balls here. Right hand side, one, two, three, four are there. But you can see the arrangement. For black ball, what is attached? White balls. Here, for black ball, what is attached? Only two red balls. For here, red ball is attached by two white balls each. So the structure is different, but element remains same. Understood? See, CH4, that means methane. It is a gas. Methane gas is combined with oxygen gas. Oxygen is also gas, right? Oxygen. So both gases combined, it gives rise to what? Carbon and oxygen combines. It becomes carbon dioxide. See here, CO2. Then what is remaining? H and O. That means HO. That means H2O. It becomes water. How many molecules of water we are getting? Two. two molecules of water. This is one molecule of water and this is other molecule of water. Clear? 3. We will understand more about the chemical reaction or chemical equation. What is chemical equation? Chemical equation is an equation where the chemicals are placed in left hand side and chemicals are placed on right hand side. So left hand side chemicals are called as reactants. That means which is ready, like a soldier, it is ready to get into the chemical reaction. Once the chemical reaction is completed, it becomes a product. That means, see, both are combining and it's becoming a product, right? Clear? The water, the pure water, you're cooking some rasam today, you're putting a water on boiling. Once the water boils, you're going to put the rasam powder and stir it. What it will become? It will become rasam. Okay, similar to that, ammonia is combined with hydrochloric acid, both is combined and it becomes ammonium chloride. So left hand side, what it is called as? It is called as reactants. What is reactants? The substances which take part in a chemical reaction are called reactants. That means which is ready to be part of chemical reaction. What a product? The new substance, the new substance with new properties and new structure is formed is called as a product. Clear? Come to the second example. Carbon, oxygen, it both combines and it becomes carbon dioxide. You might be wondering what is this AQ in the bracket, what we are given. Here also AQ, here also AQ, here I given S, I given G, I given G. Do you see this equation? I given S, G, S. What is that? AQ means aqueous solution. S means carbon is in the form of what? Solid. Oxygen is the form of gas. Carbon dioxide is a gas. So we need to represent Mg. What is Mg? Magnesium. Magnesium is a metal. Metal is always solid. Okay, and it combines with gas and it becomes solid. So that is the meaning of it. We'll learn about that later. But see the second example. So carbon combining with oxygen, it becomes carbon dioxide. See, solid is getting combined with gas, it becomes gas totally. Clear? So what is the reactants here? Carbon and oxygen, which is ready for chemical reaction, which is taking part in the chemical reaction, is called reactant or reactants. And the final product which you are getting is called as products. Product may be 1, it may be 2, it may be 3, it may be 4. Okay, it depends on the reactants and the chemical reaction. Okay, this is a very simple example for you people to understand. And coming to magnesium and oxygen, what is magnesium? Metal. See, this is magnesium. This is magnesium strip which we have taken here, and it has been held in a tong. This is tong, and we are giving the fire for it. Once it is kept in the fire, what will happen? It will start burning like a cracker. Okay, like a cracker, it burns. And after that, what will happen? If we put it on the glass container and powder it, it will become a powder. So magnesium is burning with oxygen. Magnesium we are seeing. Where is oxygen? Oxygen is in the surrounding air. So oxygen is present in the surrounding air. So oxygen combining with magnesium, how it is getting reacted? Because to burn, what is required? Oxygen is required to burn. So obviously oxygen is combining with magnesium and it is burning. And what we get as a final product? It is a solid. It is called as magnesium oxide. Clear? So what we learned now? We learned about a chemical equation. Chemical equation. Chemical equation consists of two parts. Left hand side is always called as reactant. Right hand product is always called product. Right hand side is always called as product. And what is there in between the arrow Y? So you can see here 1, 2, 3. All arrows are pointing towards right side. Why? Because it shows the direction of chemical reaction towards the product. It shows the direction of chemical reaction taking place towards the product. Clear? Examples of chemical reactions. Give us some examples of chemical reactions. If someone has, what will say? In a house only we can see so many chemical reactions. What is souring of milk? If you keep milk for some day, 2 days, 3 days, what will happen? It will become sour. Okay, so the milk becomes sour. Why? Because of chemical reaction. In the night, there is a milk, and to the milk you put some curd. or the buttermilk and keep it for the overnight. Morning, what it will become? Will it be milk? No, it will be curds. How? Because of chemical reaction. Cooking of food, as I said, to water you put some masala, it will become rasam or it becomes sambar, right? So cooking of food is also a chemical reaction. Example of chemical reaction. Digestion of food in our body produces hydrochloric acid inside. Okay, when the food, because of metabolism, the food breaks down into smaller pieces and chemical action happens because of hydrochloric acid, and the nutrients are getting into the bloodstream because of chemical reaction. Process of respiration, you take in what? Oxygen. You're taking in oxygen, then after some time you leave out the air. What do you leave out? You leave out carbon dioxide. And what is the carbon dioxide consists? It will be hot or cool? It will be warm. That means it is hot. While entering inside, it will be cool. Oxygen will be cool. While coming out, the carbon dioxide will be hot. Why? Because of exothermic reaction. That you will understand in the next chapter. Then fermentation of grapes. What is fermenting? Fermentation is nothing but converting sugar into alcohol. That is nothing but fermentation. Have you seen fermenting of grapes? Once the grapes are fermented, it becomes wine. How the wine is prepared? Take some grapes in a container and add equal amount of. If you take 1 kg of grape, you have to take 1 kg of sugar. Put it to in the container and smash it with the hand nicely. Okay, smash it so that it becomes juice, then boil it very nicely, and once it cools, put it in a container, closed container, and keep it for 30 days. What will happen? All the sugar in the grape solution, it becomes wine. And rusting of iron, have you seen this yellow color or golden color thing? What is that? Rust. That means iron is getting reacted with oxygen, it becomes iron oxide. So that is nothing but rust. Then burning of fuel, when you burn the stick, what will happen to the stick? It burns away and it becomes ashes. First it will turn into charcoal, charcoal will become into ashes. Okay, that is also chemical reaction. Ripening of fruit, everyone likes mangoes, isn't it? How does a mango gets ripened? Because of some chemical inside the mango. Over a period of time, over some time, with a little bit of heat, it turns into yellow color. That means it will become ripened, which is ready for eating. Formation of a precipitate, change in color, change in temperature, change in state. If any one or two or three, anything. So if these are present, it may be one or many. If this is present while observing, then we say that yes, chemical reaction has occurred. So that's why we call these five as characteristics of chemical reaction. So this is very, very important. You should. Okay, what we have learned is chemical equations already. We'll go for the definition of it. The method of representing a chemical reaction with the help of symbols and formula. That's it. Okay, it is known as chemical equation. Chemical reaction we know. The chemical reaction as per represented in some form. What form? In the symbol form. See, in the chemical equation, there are two types of equation. One is word equation, other one is chemical equation. What is word equation? Zinc plus sulfuric acid gives to, what is this? Left hand side is always reactants, you should remember. Right hand side, see here, two products are there. One product is zinc sulfate, other product is gas, that is hydrogen. So left hand side is reactant, right hand side is product. What is the arrow? Sorry, the arrow indicates here. The direction of the arrow indicates the chemical reaction is taking place in from left direction to right direction, and it is pointing towards the product. From the reactants to, it is getting converted to product. That is the meaning of an arrow. What is a word equation? What is a word? English word. Zinc. It is spelling Zinc. It forms zinc, right? So that is word. It becomes too much lengthier for a chemists to write everything in a paper. It contains, it consumes so much of paper. It is waste. So that's why to become easy, we will go for symbols. What is symbol for zinc? Zn. What is the symbol for sulfuric acid? H2SO4. What is the symbol for zinc sulfate? ZnSO4. What is the symbol for hydrogen? H2. So this is the chemical equation. Understood? Chemical equation, word equation and chemical equation. So this is the chemical equation with the help of symbols. Okay, clearly the definition says the method of representing a chemical reaction with the help of symbol. Okay, with the help of symbol. That means this is not a chemical equation. That is a word equation. This is the chemical equation. Why? Because everything is represented by symbols. So left hand side is called as reactants, right hand side is called as products. Hope you are clear. So equations, chemical equations we know. Then there are two types. One is balanced equation, other type is unbalanced equation. What is balancing? That means we'll see the definition. A balanced equation, a balanced chemical equation has equal number of atoms of different elements in the reactants and products. Equal number. As already we have seen in the page number 2, it is same. See, methane and oxygen getting reacted, and what are the products coming? Carbon dioxide and water. If you see here, same thing. Black color one is there, here also one is there. 1 2 3 4 white balls are here. Here also 4 white balls are here. 1 2 3 4 red balls are here. Here 1 2 3 4 red balls are here. That means it is telling equal number of atoms. Okay, in reactants and products. How much number of atoms are present in left hand side, so many number of atoms should be present in right hand side also. Okay, but elements are different. Elements will be different. See, what is CH4? What is C here? Carbon. That is black ball is called as carbon, and hydrogen are 4. 1 2 3 4. Hydrogen is 4. That means white color is nothing but hydrogen is 4. In oxygen, two elements of oxygen. Oxygen is always in joint form. That is O2 is oxygen. That means 1 2 is combined. That we call it as oxygen. How many elements are there? 2 O2. That means O2 O2. That means one O2 second O2. So two O2s are there. That means two amount of oxygen is present. Two elements of oxygen are present. Here you come and see CO2. What is C? Carbon. Oxygen, only one oxygen. So combine it. O2. Here come, what is here? This O2. That means O1, that is O2 O2 O2. So two O are present here, correct? For that you attach hydrogen. So you have seen here white things are hydrogen. So 1 2 1 2 is attached here. So what is this? Totally it is water. This is water. How many elements of compounds of water are there? 1 2. That's why 2 H2O. You are able to understand slowly. Once we start balancing the equation, we will come to understand how to balance the equation. So as per this definition, we can relate it to law of conservation of mass. What does the law of conservation of mass say? It say energy can neither be created nor destroyed. So this law of conservation is related to the balance of equation. So coming to the same, zinc plus sulfuric acid, H2SO4 sulfuric acid, it gives two products, zinc sulfate and hydrogen. So we'll balance the equation. How to balance the equation? First we have to go for a table. Write the table like this. And what are the elements present? All the elements has to be individually it has to be written. Zinc, okay, zinc atoms, H hydrogen atoms, S sulfur atoms, O oxygen atoms. So once we write down left hand side, right hand side also same number, same number of elements will be present. That we know. We are very clear from the definition. So right here in reactants and in products. So what does the balance equation formula holds? So it holds, it tells us number of atoms of the elements in the left hand side should be equal to number of atoms of the elements in the right hand side. So in reactants, in zinc, how many atoms are there? Left hand side it is 1. In products, how many are there? Zinc is 1. Okay, it is balanced. Hydrogen here 2 are there. Here also 2 are there. 2 2. So it is balanced. Sulfur, how many are there? 1 1. So 1 1. So it is balanced. Number of oxygen atoms. How many are there? O4, O4, 4, 4. So it is balanced. So we say that this equation is balanced. Why it is balanced? So number of atoms on left hand side will be equal to number of atoms on right hand side. So it will be balanced. That means 100 kg is there on left hand side. Right hand side how many kg should be there? 100 kgs. So it is balanced. Clear? A balanced chemical equation has an equal masses of various elements in the reactants and products. Now we understood balanced equation. Come to unbalanced equation. What is unbalanced equation? That means in the equation, left hand side of atoms, left hand side atoms will be not equal to the right hand side atoms. That means if left hand side 100 kg is there, right hand side 80 kg, will both balance in a physical balance? No, it will not balance at all. One will go up and other will come in bottom. So it is not balanced. So we have to balance the equation to make it stable. Clear? Take an example of hydrogen plus oxygen element. These are reactants is combining and becoming a product. What is the name of the product? H2O. What is H2O? Water. Now again write the table. If you write the table only, you will get marks in the exam. Otherwise, no. Follow this procedure. Right here, number of left hand side come here. Element number 1, what is that? Hydrogen. Number of hydrogen atoms. Atom number 2. Element number 2 is oxygen. Number of oxygen atoms. Come here in reactants, in products. So in reactants, hydrogen how many are there? 2. 2. In products how many are there? Hydrogen 2. 2. So hydrogen is balanced. We need not worry at all. Come to oxygen. How many are there left hand side? 2. Right 2. Right hand side only 1 is there. 1. Is it balanced? No. It is not balanced and it is not acceptable. Already we have seen law of conservation of mass. Energy can neither be created nor destroyed. That means left hand side number of atoms on left hand side should be equal to number of atoms on right hand side. So that's why it is called as an unbalanced equation. Is this equation balanced? No, it is not balanced. Why? Because number of oxygen atoms on the left hand side is not equal to the number of oxygen atoms on the right hand side. Hope everything is clear. Now we'll see the procedure of balancing of chemical equation. Come here. The process of making the number of different types of atoms equal on both the sides of an equation is called the balancing of equation. We know balanced equation. What is the definition of balancing equation? Balanced equation. Amount of atoms on left hand side should be equal to amount of atoms on right hand side. Clear? See, what is the balancing of equation definition? The process of making the number of atoms on left hand side to be equal to number of atoms on the right hand side. That's it. Very simple. Okay, write a table here. Okay, hydrogen atoms, oxygen atoms, element, hydrogen element, oxygen element. Then here left hand side, right hand side you need not write because the same element on the left hand side will be equal to right hand side only. So in reactants 2, hydrogen is 2. Here product hydrogen is 2. Left hand side oxygen. How many elements are there? 2. Atoms are there 2. Here hydrogen oxygen, how many elements are there? Only 1 is there. Only 1 atom is there. So it is not balanced. Not acceptable. Now we need to make it balanced. Come, let us make it balanced. Again write the same table, copy the same table here and leave all these things blank. Now we will go write number because it should come 2 here, right? So what we can make to make it 2? We can add 2 here. You can write 2 here. So it becomes 2 atoms of oxygen so that it can be balanced. So 2 will should come. Now what will happen to the hydrogen atoms now? 2 2s are 4. That means it will not balance here, correct? So what we have to do? We have to write 2 here. That means 2 2s are 4. Okay, 2 2s are 4. 2 2s are 4. So hydrogen is balanced. See here also same reactants. Now, what will happen to left hand side? 2 2s are 4. So 4. Right hand side hydrogen 2 2s are 4 4. It is balanced. Good. Come to oxygen O2. How many are there? 2 atoms of oxygen are there. Come here. 2 oxygen are there. 2 atoms of oxygen are there. Okay. So 2, you should write 2 here. So equation is, this is a balanced equation. This is unbalanced equation. This is equal e- balanced equation. Clear? See, important note. Always three elements present in the form of diatomic molecules. Sorry, not three. There always these elements present in the form of diatomic molecules. That means two atoms always will be present as one. So that's why it is called as diatomic molecules. Diatom. See, oxygen is a diatom. Why? Because always two oxygen atoms will combine and it will be in the form of that, we call it as oxygen. So equations to be balanced accordingly. See, oxygen means we should not write O. How we have to write O2. Hydrogen means we should not write H. How we have to write H2. Similarly, nitrogen N2, fluorine F2, chlorine Cl2, bromine Br2, iodine I2. So you should remember these kind of things. Okay, you should remember. And all these rules we have to remember. See, instead of there, we could have written the 2 here. No, we cannot write. Why? Because the rules. That's why the 2 has to be written here only, not here. H2O2. Will H2O2 make any chemical? No. So to make it a valid chemical, 2 has to be written here only. So slowly observe all these things. So it becomes very easy for balancing the equation. So you can practice at the class or from the textbook questions balancing the equations. Okay, any doubts you can reach out to the teacher, respective teacher. Now coming to the next topic, types of chemical reactions. Okay, chemical, we know what is chemical balancing. Chemicals we know, chemical reactions we know. Now we are going to types of chemical reactions. First we'll go for combination reaction. What is a combination reaction? Combination, as name says, something will combine and it become one. You can see here. Okay, calcium oxide, quicklime, calcium oxide plus water, calcium oxide plus water combines, it becomes calcium hydroxide. That is nothing but calcium oxide. Calcium oxide, other name for calcium oxide is quicklime or lime. Okay, it can be called as lime or quicklime or calcium oxide. Okay, and when it mixes with water, it becomes calcium hydroxide. We know what is this. S is solid, L is liquid, AQ, what is AQ? Aqueous means aqueous solution. What is aqua? Aqueous solution. That means some solid is mixed in water and kept it. That solution is called as aqueous solution. For example, take a beaker, take a tumbler at home, put some water and put some 2 spoons of salt or sugar and stir it thoroughly. After some time, it will become one. So what is that solution? That solution is called as aqueous solution. Okay, same thing in the water. What is there? Calcium hydroxide is there. It is also called as slaked lime. So that is called as aqueous solution. You see here how many reactants are there? Two reactants are there, calcium oxide and water. Two reactants are combining to form what? Product. Okay, reactant 1, reactant 2 combining to form calcium hydroxide product. So that is called as combination reaction. Second, carbon plus oxygen combined to become carbon dioxide. Okay, these two reactants are combining to form a single product. That's why it is called as combination reaction. Combination reaction. And coming to the third example, you see formation of water, very easy and simple. Already we have seen it. Hydrogen plus oxygen both combined to form water. So that is nothing but, that means combining, joining. Okay, the reactants join, combine to form a product. So that's why it is called as combination reaction. Hope you are clear. Already we have seen this example, calcium hydroxide example only is given here, and already we have seen this reaction is nothing but exothermic reaction. So this is also called as combination reaction. Clear? This glucose combines with oxygen in the cells of our body and provide energy. Okay, the glucose combines with oxygen in the cells of our body and provides energy. The special name of this reaction is called as respiration. Okay, respiration. This is also an example of combination reaction. Why? Because glucose is combining with oxygen, right? That's why we call it as a combination reaction. The reactions in which heat is released along with the formation of products are called as exothermic chemical reactions. We have already seen what is exo. Exo is associated with hot. Hot is associated with exo. Those words, both words you should remember. So hot means exothermic reaction. That means once the chemical reaction is produced, is completed, if you touch the container, okay, or the product, what will be feeling? What you will be feeling? You will be feeling it very hot. Okay, that is called as exothermic reaction because the heat is released. That's why it is called as exothermic reaction. Coming to the second type of chemical reaction, that is called as decomposition reaction. What is decomposition? You have seen the composition, combination. That means two reactants or three reactants combine. Decompose means it breaks down. That means you can see here ferrous sulfate. This is a compound or an element compound. It is once the heat is given to it, that means it has been fried. Okay, it has been fried. What will happen? It decomposes. That means it breaks down into ferric oxide, sulfur dioxide, and sulfur trioxide. Okay, clear? That is called as decomposition reaction. It decomposes, it breaks down, it breaks down. And example number two, calcium carbonate, limestone. Okay, calcium carbonate, once the heat is given to it, what will happen? It breaks down into calcium oxide and carbon dioxide. What is limestone? The limestone is the one which is applied. It is mixed with the water and it is applied onto the wall. Correct? Once the heat is given, it becomes quicklime and calcium oxide. Example number three, lead nitrate. Lead nitrate, once the heat is given to lead nitrate, what will happen? It decomposes into three products. One, two, three. What is it? Lead oxide, nitrogen oxide, and oxygen. So it is decomposing. Example number four, sodium chloride. Okay, sorry, silver chloride. Ag is silver. Silver chloride. When heat is given, that means sunlight is given. Sunlight is nothing but heat. When heat is given, what happens? It breaks down into pure silver and chlorine gas is liberated. See here, this is the example. See, this is a china dish. In the china dish, you keep silver chloride, and to silver chloride you give sunlight. You expose it to sunlight. What happens? After some time, all the chlorine content in the silver chloride that evaporates as gas and pure silver is obtained. This is very important and they will ask in the exam. Example number 5, silver bromine. Okay, silver bromide. Silver bromide, similar to this, silver bromide is exposed to sunlight. What will happen? Bromine is released or goes out from silver bromide as bromine gas. Br is bromine gas, and pure silver is obtained. Understood? Decomposition is opposite of combination reaction. Combination means three or four compounds or elements combine to form a product. But here in decomposition, the one compound is decomposed, or decompose means broken down into different compounds or elements. Clear? Displacement reaction. What is displacement? As the name says, displacement. That means changing the position. Changing the position. Okay. See here. I'll explain these pictures later. You can just see here. Okay. What is Fe? Fe is means iron. Iron. Iron plus copper sulfate. It is a solution. Ferrous iron is a solid. That's why S solid. Copper sulfate is a solution. In distilled water, you just put copper sulfate powder, mix it well. It becomes a solution. See this blue color what you are seeing here, the blue color what you are seeing is a copper sulfate solution. Okay, so iron when mixed with copper sulfate solution, what will happen? It becomes copper sulfate. Copper sulfate solution is formed, product plus pure copper is deposited. Okay, pure copper is deposited. You can see here ferrous is alone here. Here is ferrous alone? No. What has happened? You can see here ferrous sulfate. Ferrous sulfate. 1 minute. I'll show with the help of a pen. See, this ferrous is getting combined with sulfur. So it becomes ferrous sulfate. Clear? And what is left alone? Now copper and sulfate are no more friends. Only copper is taken out and is written separately here. Okay. This copper is taken out and separately written here. Clear? Clear? Copper sulfate solution. And here also come to example 1. Here also if you see zinc and copper sulfate. Instead of iron, go for zinc. Okay, zinc and copper sulfate. What should happen? As we see, zinc and sulfate will become friends. So that way it will become zinc sulfate. And what is left over here from sulfate? Only copper is left over. And copper has to be written separately. See all these chemical reactions, this chapter is very easy unless otherwise you practice number of times. Okay, then you should remember everything. Then come to this example, lead and copper chloride is there. What will happen? You know very well. Yes, come on. Lead and copper is combined, it becomes lead chloride solution. Okay, what is left over? Our friend copper is left over, so he has to be written separately. Understood? That is displacement. That means this position is changing, copper position is changing. See, copper is getting combined with zinc. Here also copper is combining with ferrous, so that's why it is called as displacement, changing the place. Changing the place or position is called as displacement reaction. Simple. Say first is combination reaction, opposite to combination is displacement, um, decomposition reaction. Third one is changing the position, displacement reaction. Now we'll come to this experiment. See this experiment. Take a stand here. All the stands will be available in your school lab. This is a test tube. Take a test tube. To that put copper sulfate solution. How to prepare copper sulfate solution? Copper sulfate granules will come, it is blue in color. Add it to the distilled water and stir it. It will become copper sulfate solution. Pour that copper sulfate solution in a test tube and take nails here. Okay, take 2 nails here. The nails has to be tied here. Keep it for some time. Okay, keep it for some time. What will happen? Both are dipped in copper sulfate solution. So before and after the experiment, see this picture shows the before and after the experiment. What will happen to the nails here? After some time, slowly, what will happen? See here, ferrous, copper sulfate. What will happen? Ferrous sulfate solution is formed, and what will happen to the copper? Copper will slowly come and deposit onto the iron nail here. Iron nail here. Okay, so that's why we are seeing this nail as copper in color. So copper will get deposited here. So because copper is separate, it is free in the solution and it will come and sit on to the iron because iron attracts copper. Clear? So this is an example. Hope it is understand. No displacement learned. Now we will come for double displacement reaction. What is that double displacement reaction? Double displacement, that both the position will change. See, very simple. Very simple. The sodium sulfate is here, barium chloride is here. What will happen? What will happen? See, as I said first, this is the rule. You combine this sodium chloride. Clear? So sodium and chlorine is getting combined. These two are becoming friends. And what will happen? What will happen to this people? Sulfate and barium. So it will become barium sulfate. See here, barium sulfate will become friends here. barium sulfate and sodium and chlorine become friends here. Okay, so these are the reactants is here, and these are the products. Clear? So that's why it's called as two times the displacement is happening, the change of position is happening. That's why it is called as double displacement reaction. And this is an example. They will ask in the exam given definition of double displacement reaction and example of it. So you have to give the example. See here the same thing. What is here, given here? Barium chloride. It is already barium chloride is here, and solution, and sodium sulfate solution is there. Both are in the form of aqua. See aqu means solution, aqueous solution. When both mix, what will happen? In the same texture both will be present. What is that? Barium sulfate and sodium chloride. So what is sodium chloride? Have you heard of sodium chloride? It is nothing but salt, cooking salt. Okay, you can taste it. So salt can be produced in this form also. Hope you are clear. Now coming to the last portion, which is nothing but oxidation and reduction. What do you mean by oxidation and reduction? The name only is telling what is oxidation, what is reduction. Let us see. Take an example here. Go to the lab with the help of the instructor. You take a burner and start burning it. Okay. Let this burner start giving out the flames, and keep a wire mesh here. That is called as wire gauge. And take a china dish. It is in a container kind of thing, which will be available in the labs. That is called as china dish. And to that you put what? Carbon powder. Sorry, copper powder. Copper powder is always will be in reddish brown in color. Put that and start frying it. Frying it. What will happen? See, copper plus oxygen. Copper is there. Copper powder is there. Pure copper, and oxygen is present in the air. And you give the heat. What will happen? It gives copper oxide. So slowly this one will become copper oxide. Okay, it is getting oxygen. So that's why it is called as oxidation reaction. Oxidation reaction. Why? Means it is getting oxygen. Copper is getting oxygen, and it is becoming copper oxide. Clear? If a substance gains oxygen during a chemical reaction, it is said to be oxidized. Very, very simple. Next, copper oxide. Already copper oxide is there. By this is a product, copper oxide is there. For that, if you give hydrogen gas over it, still further you heat it in the same fashion, and here you can give the hydrogen gas. Hydrogen gas is, if you give to the same product, what will happen? Under heat, again it decomposes. See here, it is becoming decomposition, or it is also displacement. Copper is losing oxygen here. That means it is reduction. Oxygen is getting reduced from oxygen. It becomes copper, and hydrogen is gaining oxygen, right? Okay, so this losing of oxygen from the copper is called as reduction. If a substance loses oxygen during a reaction, it is said to be reduced. Very, very clear. Oxidation. What is oxidation? During a chemical reaction, if you gain the oxygen, if you gain the oxygen, what is reduction? Oxygen is getting reduced during the chemical reaction. Very, very simple, and you should remember all these examples. What is example? Zinc oxide plus carbon. What is happening to the oxygen is here? It is getting reduced, it is getting removed, and it is becoming only zinc here. Okay, oxygen is reduced from zinc. That's why it is called as reduction. Okay, and magnesium oxide plus hydrochloric acid. What is happening here? Oxygen is getting reduced. See here, there's no oxygen along with magnesium, manganese. Okay, manganese. So manganese oxide is becoming manganese chloride. Okay, so oxygen is getting reduced, so it is a reduction reaction. So one reactant gets oxidized while other gets reduced during a reaction. Such reactions are called oxidation reduction reactions or redox reactions. Clear? Redox reactions. See here, it is a redox reaction. How? Because see here, the same example has been taken here and written here. Same example is taken here. Copper oxide plus hydrogen under heat. is done, so it becomes copper and oxygen is getting reduced. But for oxygen, what is happening? Oxygen is gaining oxygen. Sorry, hydrogen is gaining oxygen. It is oxidation reaction. Copper is reducing oxygen, so it is reduction reaction. So since both oxidation and reduction are present here, it is called as red ox reaction, or it is red OX ox, so red ox reaction. Okay, it is called as oxidation reduction reaction, or in short form it is called as redox reaction. So these are very important from the examination point of view. Coming to the last portion, okay, what is this? Have you observed the effects of oxidation reactions in everyday life? Oxidation reactions, yes, we might have seen, but we might have not observed properly and understand whether that is oxidation reaction. But everyone would have seen. Okay, so that application is nothing but corrosion. What is corrosion? Corrosion is nothing but rusting. You can see the chains are got rusted. This has got rusted. The metal portion has got rusted. The tire rim, the axle rim and nuts have got, studs have got rusted. So when a metal is attacked by a substance around it, how it will get rusted? Because of moisture and acids. If you pour some acid onto it, or if you pour some salt onto metals, it becomes rusted because of the moisture content outside. If you keep the vehicle or the chains or some plates outside, what will happen? It absorbs moisture and it becomes corroded. What is that? Corrode means removing the metal. See, all the surface is getting removed or corroded. That's why it is called as corrosion, right? One other term is very important is rancidity. What is rancidity? Rancidity is also called as rusting. Okay, rusting of what? Rusting of apple, potato chips. Sometimes if you open for too long time, if you keep it and if you smell it, it smells very bad. Okay, so that is nothing but rusting. And what is this? Some bread. If you cut it, you can see it has got fungus and all. And if you smell it, you smell bad. What is called as? That is nothing of rusting of food. Rusting of food is called as rancidity. See, when fats and oils are oxidized, fats and oils are oxidized, they become rancid and they smell and taste bad. Clear? So corrosion and rancid. And we come to the end of this chapter 1 of chemistry, the chemical equations. So any doubts, please reach out to the respective teacher and get the doubts clarified. Thank you so much.